Let's get started with a very basic description of current flow. Inside an atom, different particles have specific electrical charges. Electrons carry a negative electrical charge. Protons carry a positive charge. Neutrons are electrically neutral. Under normal conditions, there are an equal number of protons and electrons within the atom, and it is electrically balanced. But it's possible to add or subtract electrons from the atom. This creates a temporary imbalance between positive and negative forces. This imbalance is the key to current flow. When an atom has an electrical imbalance, electrons tend to move between atoms. In fact, electricity can be defined as the movement of electrons from one atom to another. The energy released as the electrons leave one atom and pass to the next is electrical energy. But why would electrons move? You may already know that like magnetic poles repel each other, while opposite poles will attract. In electricity, just like magnetism, opposite charges attract and like charges repel. When an electron leaves the orbit of an atom, the atom has a more positive charge. The negatively charged electrons are then attracted to that positively charged atom. At the same time, additional electrons, because of their negative charge, are repelling or pushing the electrons from one atom to the next. They will continue to do so as long as there are an excess of electrons in one place, a lack of electrons in another place, and a conductor or pathway between the two. While there are many theories about the nature and direction of current flow, for now it is important to remember that electricity must have a positive and a negative polarity. Remember that among the elements we have a wide range of materials. Some of these materials are called conductors because they allow electrical currents to pass through them easily. Other materials do not allow current to pass through them easily and are known as insulators. A third group of materials whose properties fall between these two are called semiconductors. Today's automobiles use all three types of materials. An average automobile has complex and lengthy wiring harnesses made of conductors such as copper. The wires are coated with different colored insulators. The insulators separate the wires from each other and from the metal parts of the car's chassis. And finally, semiconductors are used in many places, from the complex integrated circuits in the automotive computer to the diodes found in the AC generator in today's charging systems. It's important to be aware that there are two basic types of electricity: static electricity and current electricity. You encounter static electricity when you touch a door handle in your house or car on a cold, dry day and feel an electrical shock, or hear a crackling sound when you run a comb through your hair. Discharges of static electricity can cause serious damage to electronic components. Current electricity is the electrical current that powers almost all electrical devices, such as the lights in your home. There are many ways to produce current electricity. Light, heat, vibration, chemical reactions, and magnetism can all produce an electrical current. Let's take a look at the connection between electricity and magnetism. Whenever an electrical current is passed through a conductor, a magnetic field is created around the conductor. These iron filings are moved by the magnetic field created by current passing through the wire. This is known as electromagnetism. The opposite is also true. A magnetic field passing over a conductor produces a voltage in the conductor. This is called electromagnetic induction. These two concepts form the basis for electric motors, ignition coils, relays, and many other electromagnetic devices found on today's cars. For electrical energy to be useful, it must travel through an electrical circuit. The simplest way to show this is a battery connected in series with a lamp. The circuit also has a switch and a fuse for circuit protection. An electrical circuit is an endless loop formed by a conductor from an electrical source, through a load, and back to the source. The power source is there to provide the force necessary to direct the flow of electrons. The load is a type of electrical device that performs some useful function, such as a motor or a lamp. Electrons leave the battery from the negative terminal, go through the lamp, and return to the positive terminal of the battery. As long as the circuit is complete, the lamp will light.